How do orbital maneuvers use reaction control systems? Imagine trying to change direction while riding a bicycle without touching the handlebars or pedals. In space, spacecraft do something similar when they need to adjust their position or orientation. Instead of a bicycle, they use reaction control systems, or RCS for short. These systems are tiny but powerful sets of thrusters placed around the spacecraft. They work by expelling gas or propellant in controlled bursts to produce forces and torques that move the spacecraft precisely where it needs to go. Once a spacecraft reaches orbit, it no longer has the big engines used during launch. Instead, it relies on these smaller thrusters to make fine adjustments. When a spacecraft needs to rotate to point antennas or sensors in the right direction, the RCS fires thrusters on one side to spin it around its axes. If it needs to shift position slightly, the thrusters push it along its velocity path or sideways. This is especially useful during docking with other spacecraft or stations, where precision is key. The RCS is also used to keep the spacecraft stable in orbit. Small forces from gravity or atmospheric drag can push it off course. The thrusters fire in tiny pulses to counteract these effects and keep the spacecraft in the right spot. They are arranged in clusters at different points on the spacecraft to balance control. The onboard control system calculates exactly which thrusters to fire and when, to perform the desired maneuver smoothly. For larger changes in orbit, spacecraft often use more powerful engines like the orbital maneuvering system on the space shuttle. But for delicate adjustments, the RCS is essential. It allows spacecraft to point their instruments, change their orbit, or dock with other objects with great accuracy. Without the reaction control system, performing these precise tasks would be nearly impossible in the environment of space. It is a vital part of satellite systems and orbital dynamics, helping spacecraft navigate and stay on course in the vastness of space.